Okay. One other question I'm going to ask of you on the final is going to ask you to write the equation of a line that's tangent to the curve that's given at a particular point. And I would like to just go through an example of one of those right now. So let's go to, I'm going to get back to the iPad and go from there. So here's the question. Write the equation of a line tangent to the curve f of x equals x to the third plus 1 at x equals 1. Okay, so again, the circumstance is you need to write the equation of a line, you need a point and the slope. The point we can get by plugging our value of x into f of x, the original function, plug in 1 into that, that'll give us our y. And then when we take the derivative, we'll have f prime of x, plug 1 into that, and we'll have the slope. So you need f of x, f of 1, f prime of x, f prime of 1. Every time you do the function, that value of x is going to be needed to plug in the function and the derivative. So let's dive right in and let's find that derivative. So f prime of x in this case is equal to 3x squared. Therefore, we want to find the slope. This is the slope of the line, right? We're going to find the slope at x equals 1. That is going to be 1 squared, which is 3 times 1, which is 3. As a result, we end up with f prime of 1 is equal to 3, which is our slope. The slope is equal to 3. So now what we need to do is we first need to determine what is the point. So f of x, we've got there, f of 1 is going to be equal to 1 cubed plus 1, which is 1 plus 1, which is 2. So we've got f of 1 equals 2, which means our point is 1, 2. Having the point and the slope, we can now write the equation of a line. So y equals mx plus b is the slope-intercept form. I'll give you these formulas again on the formula sheet. We need to plug in our x and our y and our m here. So we've got y equals mx plus b. Therefore, b equals 2 minus 3, b equals minus 1. So we've got y equals mx plus b. There's the equation of the line. And the other way, the formula we could use is y minus y1 equals m times x minus x1. This is point slope form. And x1, y1 is the point, and m is the slope. So we've got y minus 2 equals 3 times x minus 1, which gives us y minus 2 equals 3x minus 3. Add 2 to each side, we end up with minus 1. There's the equation of the line. So I'm going to encourage you also, go in on your calculator or in Desmos and verify that it works. Let's go in right now into Desmos and just verify that this thing does give us the, that it does cross tangent line at the point that we're concerned about. So I've got Desmos here somewhere, don't I? Let's see. I want Desmos. Okay, here we go, Desmos. I've gone ahead and typed in the two circumstances that we're working with here. I've got y equals x cubed plus 1. There's that function. Notice it's x cubed function that goes to the origin, shifted up one place. And then I'm also going to write the equation of the line. I've written it down here, just mx plus b. But let's say I make a mistake, okay? Let's say I went in, that's the answer that we got, y equals 3x minus 1. Let's say what if I plugged in plus 1? For some reason, I plugged this in instead. What does that graph look like? Okay, does that touch at x equals 1? No, it does not. You know, the situation where at x equals 1, we would be touching right here. It's not. Something's wrong with this picture. And I can look at this and realize, yes, I need minus 1. The equation I have on my sheet is minus 1. So let's change that puppy to minus 1. And we end up now looking at it, and we can see that the line and the curve, they touch. The line is tangent at the point 1, 2, notice. And that's the situation. Verify your answers right and go from there, all right? So with that, that's going to be on the final exam. I'll ask you to do it. You check that yourself. It's up to you to check it, but Make sure you're confident with that. I'm going to ask you on the final. So be well. I'm going to go ahead and finish that, and let me know if you've got any questions. Pay attention to, watch it, rewatch this again, and get solid on it, all right? It'll be on the final.